find the effective rate corresponding to the given nominal rate. So basically, it's 8% per year compounded daily. So according to this, I'm just going to plug it into the formula. The effective interest rate is equal to 1 plus r over m to the m power minus 1. And so when I plug those values in, r is 0.08, m is 365. And when I compute that out, I get about 0.0832775, blah, blah, blah. And, changing the decimal over, rounding off a little bit, it's approximately 8.33% interest. So this 8% interest per year compounded daily has an effective rate of 8.33% applied in that one time per year. One of the things that your book likes to do is throw a lot of formulas at you. And the fact of the matter is, you really do not need another formula to do this. That formula we have for compound interest will satisfy a lot of different conditions in this particular part of the lesson. So let me show an alternate method of doing the same calculation. All I'm going to be doing is I'm going to be using the a equals p times 1 plus r over n to the nt power. So the other thing I'm going to be doing here is I'm just going to say, okay, what happens in a year if I, apply this interest? Now, I don't know what the principal is because they don't really give us a given rate. And it really doesn't matter. If you want to make up your own value for p, that's fine. But you don't really have to, because say I'm doubling something in a year. Well, if I have a particular rate that will double amount in a certain amount of time, it doesn't matter how much that is to double. If I go from $1 to $2 or $1 million to $2 million, that doubling time will be the same. So I'm just putting the values in where they go, and when I calculate this out, I get that the accumulated amount is the principal amount times 1.083277572, which is like, the decimal part we've seen in the previous answer. What this means and how I would interpret that is that in 1 year, the accumulated amount is 108.33% of the principal for an 8.33% increase. That 8.33% increase is what the effective rate is. That's how much we actually grew in that year. So all you really have to do is just apply the same formula for a year. Don't have to worry about what the principal is. If you want to make up a number, you can make up a number, but then you want to compare accumulated amount to the principal amount so you get an idea how much it really grew. And that amount of growth is the effective rate. So the conclusion from this is that the previous formula is really not needed. Again, I'm a big proponent of memorize the formulas you have to and be able to derive the rest. Same thing with this. I don't need to have an effective rate formula because the effective rate formula is basically just an offshoot of this.